All right, good evening, Algebra 1. After doing some soul searching this weekend, I decided that we're going to go ahead and skip those two lessons discussing quadratic and exponential functions for the time being. We're going to come back to them when they're necessary, and we're going to go a little deeper on them. So for the time being, we're going to go ahead and continue on. We're going to jump into lesson 4, analyzing graphs. In this one here, we're looking at water usage during a typical day at school. Okay. So water consumption in a typical school day. So let's take a look at the graph. Okay. Trying to figure out why my, there we go. I was wondering why it was crooked. So we've got water consumption in a typical school day. So exercises 1 and 2. So the bulk of water usage is due to the flushing of toilets. Each flush, and I'm going to make sure I'm going to be doing some underlining here. So each flush uses 2.5 gallons of water. All right, Samson estimates that 2% of the population uses the bathroom between 10 a.m. and 10:01 a.m. right before homeroom. What is a good estimate of the population? So we're looking at a good estimate of the population of the school. Okay, so here's the thing. So 10:01 is approximately right here. Okay. So if that's 10:01, that means we're looking at 80 gallons of water that gets flushed in between 10 o'clock and 10:01. Okay. Now, Samson here says that's 2% of the school population. Okay. He wants to know a good estimate of the school, good estimate of the population of school. Well, we need to find out exactly how many people are flushing the toilets then. So if we're looking at, let me give you a little bit more room here to look at here, okay? So if we're looking at, okay, so each person, all right, flushes 2.5 gallons. All right, currently 80 gallons was flushed at 10 o'clock. Okay, so how many people flush the toilet? Oh, come on, this is going to be simple. This is a division problem easily. So 80 gallons divided by 2.5. I hate decimals. So division with decimals, division with decimals. Oh, that's right. I can multiply both 2.5 times 10 and 80 times 10 to get rid of that decimal. So instead, this is 25 divided into 800. Okay, well, that's good. It's an easy thing to get rid of. So how many times can 25 go into 80? Well, let's see. 25 times 3 is 75. So I subtract, I get 25 and 0. Okay, so 25 can go into 200 and, ooh, wait a minute. I'm sorry, yeah, I put 5. I put a 2. Why did I put a 2? I'm silly. So I get 50. So 25 can go into 50 2 times. So we know that there are approximately 32 people flushing at this time. Now he says that's approximately 2%. Okay. Now there's many different ways you can go about doing this. Okay. One of my favorite ways is doing this. So 100% equals, I don't know. Okay. But I know that 2% equals 32 people. Okay. So now I can do a little bit of multiplication because basically these are proportions. I'm looking at a proportional relationship, so I just got to get my way moving up there. Okay. Well, I know that if I take 2 and I multiply it by 5, I get 10%. And if I take 32 and multiply it by 5, okay, I get 160. Okay. So what number can I multiply by 10 to get 100? Oh, that's easy. I can multiply that by 10 and then take 160 and multiply it by 10, and I get approximately 1,600 students. There are 1,600 students at Sampson's High School. Okay. Now I know you're like, Mr. Hale, what did you just do? If you have questions about what I did, remember proportional relationships. If you still don't understand what I did, ask me tomorrow in class. I will show you how I did this and how it works. Okay. I can also show you proportional relationship method as well, show you how this all works. Okay, but for right now, just be happy with the answer as being approximately 1,600 people. Okay, there are approximately 1,600 people in his school. All right, so continue on. So Samson then wonders this. If everyone at the school flushed the toilet at the same time, how much water would go down the drain? Are we able to find the answer for Samson? Yes, we can. Yes, we can. How do we do that? It's a simple multiplication problem. If we know that there are approximately 1,600 people, and we know that one person flushes 2.5 gallons, then all we got to do is what? Correct. All we got to do is multiply. So we got 1,600 times 2.5. 5 times 0 is 0. 5 times 0 is 0. 5 times 6 is going to be 30. Carry the 3. 5 times 1 is 5. Plus 3 is 8. Now, we put a placeholder in the ones place because we're moving from what basically would be considered the ones place to the tens place. So that is the reason why we move to the tens place when we start multiplying. 2 times 0 is 0. 2 times 0 is 0. 2 times 6 is 12. Scratch out that 3, carry the 1. 2 times 1 is 2, plus 1 is 3. So now we add 0, 0, 0. 8 plus 2 is 10, carry the 1. 3 plus 1 is 4. Is it 40,000? No, it's not, because I have a 1 decimal place here. If you remember, if we got decimals, we got to put the decimal place. So I put it right here. Okay, so approximately 4,000 gallons would be flushed at one time. 4,000 gallons. Okay, so now an estimation activity. Okay, so make a guess to how many toilets are at the school. Well, we sat there and said that 32 people flushed the toilet at one time, so we can assume that there are 32 toilets. All right. So, I mean, there's a lot of stuff that we can do here. There's a lot of stuff that we can estimate here. All right. So, let's see. So, let's go through this. So, make a guess to how many toilets are at the school. All right. Let's run with our school. Since it's not specifying their school, it's just saying make a guess at how many toilets are at the school. So, let's make a run at our school. So, I know that there is a boys and girls bathroom near my room. There's a boys and girls bathroom near Miss McGar's room. I know there's a boys and girls bathroom down the hallway down near the sped teachers. So that's 3 boys and girls bathrooms. Now, if I mimic that, would be downstairs as well. So that's 6 boys and girls bathrooms. There's probably one in the gym, so boys and girls bathroom in there. So that's 7 boys and girls bathroom minimum. I would say there are 3, so maybe 7 per boys and girls. So I would estimate there are about 49 toilets in our room, in our school. Okay. So make a guess to how many students are in the school and what percentage of students might be using the bathroom at break times between classes, just before the start of school and just after the end of school. Are there enough toilets for the count of students wishing to use them? So, let's see. Make a guess as to how many students are in the school. Well, if I had to guess, you've got plenty of home rooms. All right, so I think you've got 8, so 24 home rooms. Minimum of 25 students per home room. So 24 times 25 would give me 0, 25 would be 120. 8, 4 would give me 600. So approximately 600 students at Mount Pisgah. Okay, at what percentage of students might be using the bathroom at break times? Well, percentage is based off of, toilets to students. So that would be 49 over 600. All right, well, we're going to be estimating here. So let's go ahead and round that up to 50 to 600. Okay, so scratch those out. So 5 divided by 60, add a decimal. So 60 into 50 gives me 0. Can't do anything with that. Add one more 0. 60 into 500, that would be an Ooh, obviously I got something wrong here. Oh, no, no, no. 16 to 500, that would be 8. 8 times 6 would be 480. Minus would be 20. All right, add another 0 is 200. 6 goes into 200 3 times. And then we get ourselves a repeating decimal again. So I got 0.083 repeating, or approximately 8.3% of the student body, or 8.3% of the students using the bathroom at any given time. So is there enough if there is there enough toilets for the count of students wishing to use them? I mean, given the fact that you're only looking at just before the start of school, just after the end of school, and break times in between classes, I don't think we have enough toilets to actually justify having 600 students in the building. So um, so using the two previous considerations, can estimate the number of students using the bathroom during peak minutes of each break. So peak minutes. Okay, well, we sat there and said the estimate is, again, we're going to estimate that about 50 students, okay, 50 students would use it during the break times. Okay, that's how many students would use the break during the peak minutes of each break. Has to be at least 50 students. Okay, so assuming each flush is used 2.5 gallons of water, estimate the amount of water being used during that peak minute of each break. So 50 times 2 is 100. 50 times a half is 25. So 125 gallons. 125 gallons of water each flush. Okay, again, if you ask me how I did that, 50 students times 2.5. Okay. What time of day do these breaks occur if the school schedule varies considering today's schedule? So what time of day do these breaks occur? Okay. Normally these breaks are going to occur what? You got homeroom, not an HB. You got homeroom. Your longest break is 15 minutes, and that's after second period. So that's going to be an after. Your next one's going to be during lunch, and then the last one's going to be after fifth period. Okay. Says draw a graph that could represent the water consumption in a school in a given day. Well, I mean, we got a pretty decent graph over here, water consumption in a typical school day. Okay. So I wouldn't expect us to do that. So no big issues there, no worries. All right. So we're going to turn the page and we're going to be looking at problem sets. Ooh, loving the problem sets. Um, I want you to do number one on your own tonight, okay? Just number one. So here's the graph and here's the questions, okay? Here's your homework. I know this is not the easiest lessons. I know we're struggling with some of this stuff. I think we're going to get through this, though. We're going to be fine. So just be patient. Be working with me. We're going to be fine, okay? This is some very interesting stuff, and I think Mr. Hale is going to reevaluate whether or not we're going to continue in Module 1. But that's what you're looking at is Lesson 4, analyzing graphs, and then we're going to do these two problems tomorrow in class as classwork, so no stress there. All right. And then we are going to move into Lesson 5, two graphing stories. Okay, so just be patient. All right, guys. I'll see you in class first thing in the morning. Have fun, and I hope you enjoyed your wonderful, amazing weekend.